All right, good morning. Welcome back to Calculus 2. We are looking at our final exam review. I believe this is problem 1A. It sure is. And we are to figure out the area between curve 2 cosine squared and 1 plus sine x. We have a y is equal to this. We have a y is equal to that. And there's a little hint that says, hey, they intersect in exactly one place. Okay, which means you're going to get something where those curves are going to look something like you've got a cosine 2 squared x, 2 cosine squared. You look at something like that, and then a 1 plus sine x, you're looking at something like this. Okay, so the idea is that you need both of these areas. So there's what you have to do is you have to find the place where they intersect. It's between here. Okay, so the first thing we're going to do is we're going to set these two equal to each other and figure out where the heck is this spot. Okay, so we have 2 cosine squared x equals 1 plus sine x. Now, if you go back and remember your trigonometric equations, you can't do this problem the way it is. You have to get everything in terms of one trigonometric equation, one trigonometric function. So you have to remember that sine squared plus cosine squared is equal to 1. Cosine squared is equal to 1 minus sine squared. So what we're going to do is we're going to say we have 1 minus sine squared x here is equal to 1 plus sine x. And then we have to go through the algebra to kind of figure this thing out. So we have 2 minus 2 sine squared x is equal to 1 plus sine x. I'm going to scoot everything over to the left, to the right-hand side here, which means we're going to add 2 sine squared x to both sides. We're going to subtract 2 to both sides. Okay, let's go ahead and see what that looks like. That is we have 0 is equal to 1 plus negative 2. We have negative 1 plus sine x plus 2 sine squared x. So again, I'm just going to rewrite this so it goes in descending form because ascending form is going to make me nervous. So we've got 2 sine squared x plus sine x minus 1 is equal to 0. So AC method, for those who might have moved before, you know, like that's my favorite thing to do. 2 times negative 1 is negative 2. So let's go ahead and see if we can't multiply out two things that are going to add up to negative 2, or add up to 1, but multiply out to negative 2. Okay, so we have 2 sine squared x plus 2 sine x minus sine x minus 1. Okay, I'm just taking the sine x and I'm saying, instead of sine x, we have 2 sine x minus 1 sine x. That's going to come back and give me 1 sine x. And then what we're going to do is we're going to factor by grouping. So I've got 2 sine x in the first pair. So what do we have left? We have a sine x plus 1 plus, and I'm going to factor out this negative 1. So we're going to say minus 1 here, so not plus, minus 1. And I factored out that negative sign on both of them, so I have a sine x plus 1. Okay, and then we're going to factor that. So we've got a sine x plus 1 times 2 sine x minus 1 set equal to 0. It's equal to 0. Okay, so we have sine x plus 1 is equal to 0. 2 sine x minus 1 equals 0. Sine x here is equal to 1/2. Sine x here is equal to negative 1. All right, where sine is equal to negative 1, x is equal to 3 pi over 2. Where x is equal to 1/2, sine is equal to, looks like going back in, this is a part of your unit circle. That's going to be, I think, pi over 6. Okay, so those are the two places it intersects. Now, let's go back here for a second. We are on the interval 0 to pi over 2. So I told you there's only one intersection. What would they intersect with 3 pi over 2? This is outside of the interval. We don't care about this at all. So where it intersects is pi over 6. All right. So we have to figure out who's bigger at 0, and it's going to cross over. Okay. It's always going to cross over. They don't like touch for a moment and then go back their own separate ways. They don't. I made sure that they would actually cross each other on this little spot here because that's what I want you to kind of figure out. Okay. Where do they begin? At x equals 0, who's bigger? Is it 2 sine squared x bigger or 2 cosine squared x? So we have 2 cosine squared of 0, okay, versus 1 minus, what's it, 1 plus sine x. No, not 1 minus, 1 plus sine x. So if I plug in 0, cosine of 0 is 1. 2 times 1 is 2. Sine of 0 is 0. 1 plus 0 is 0. So 2 versus 1. This one's the bigger one. So what we're going to do is we're going to break this up into two different intervals. We've got a 0 to pi over 6 And then we've got a pi over 6 to a pi over 2. Like, what are we actually doing here? We have 2 cosine squared x, okay, minus, right, minus 1 plus sine x. Okay, so let's go ahead. Minus parentheses 1 plus sine x. Okay, here we're going to have 1 plus sine x minus 2 cosine squared x, right? So we're not quite there yet. We want to integrate. As you're going through your calculus 2 stuff, the biggest mistake you can make for calculus 3 is to integrate cosine squared and say, oh, it's cosine cubed over 3. Like, no, your calculus 3 teacher will hit the roof if you do that. They'll come back to me and say, God, you didn't teach this guys anything. So you wanted to go back and look at this and say, okay, what is cosine squared? So we have to go back and say we have cosine of 2x is equal to 2 cosine squared x minus 1. And then we're going to solve for it. So we have 2 cosine of 2x plus 1 is equal to 2 cosine squared x. Do I have to divide by 2? Not really, because look, there's already a 2 cosine squared here. So I'm just going to replace it. So we've got the integral 0 to pi over 6. We've got cosine of 2x plus 1, right? That's what this factors into, minus 1 minus sine x. Okay, so we're going to go ahead and sort that out for a moment. Okay, so we've got 0 to pi over 6, cosine of 2x, hey, plus 1 minus sine x. Let's see what happens with the other little piece here, because we also have integral of pi over 6 to pi over 2. And we're going to do a little bit of algebra over here to say we have 1 plus sine x minus, and then we have 2 cosine squared x, and that's equal to cosine 2x plus 1. Okay, distribute the negative signs. We have 1 plus sine x minus cosine 2x minus 1. Again, there's some stuff that cancels. So we have sine x minus cosine of 2x. So we have sine x minus cosine of 2x. And now we just have to integrate this thing. Okay, we have to integrate and then plug our limits in. Okay, and that's our job. So derivative of sine is cosine. So when I go ahead and integrate this, I've got 1/2 sine of 2x, right? We have a u substitution here, plus cosine x. Remember, derivative of cosine is negative sine. So if I take my derivative, I get back the same thing. And we're going to go from 0 to pi over 6. Okay, plus region number 2, and we're going to go from pi over 6 to pi over 2. Okay, so this is going to be, it looks like integrating this, we have negative cosine x, because again, derivative of negative cosine is going to be a positive sign, minus 1/2 sine of 2x. The 1/2 comes from the fact that I need a u substitution here. It's just that we've done this all semester. I'm going to go ahead and do that. And we're going to go from pi over 6 to pi over 2. But don't answer yet. There's a lot of negative signs here. I don't like a lot of negative signs. So I'm going to say minus parentheses cosine x plus 1/2 sine of 2x as we're going from pi over 6 to pi over 2. What I'm going to do is I'm going to say, hey, we swap the order of integration, we get rid of the negative signs. We have plus cosine x plus 1/2 sine of 2x going from pi over 2 to pi over 6. And then over here, we're going to say we have, what are we doing here? We have 1/2 sine of 2x, 1/2 sine of 2x plus cosine x going from 0 to pi over 6. Now the fun part begins because we have to go ahead and deal with the fact that we have arithmetic. Okay, we have 1/2 2 times pi over 6 is going to be pi over 3. So we have 2 sine pi over 3 plus cosine pi over 6 minus 1/2 sine of 0, because we're looking at the 0, plus cosine of 0. And that's all minus here. Okay, this is all region number 1. It's area 1. Plus, and then I have to go ahead and deal with area number 2 here. Okay, we'll do that in a minute here. So I've got plus, I've got cosine of pi over 6 plus 1/2 sine of 2 times pi over 6 is pi over 3 minus, and then we have to go ahead and deal with this, cosine of pi over 2. Is it plus? It is plus 1/2 sine of 2 times pi over 2, which is going to be pi. Okay, it's just going to be pi. Okay, and now we just have to go ahead and do some arithmetic for what's going on here. Again, notice these are nice angles. They are on the unit circle. If you don't remember them, you should go back and remember them. But I'm not taking your calculators away from you. You can remember like, oh, 0.866, that's square root of 3 over 2. Yeah. So we have 1/2, remember sine of pi over 3, square root of 3 over 2. Okay. Plus sine of pi over 6, that's going to be square root of 3 over 2. Okay. Minus 1/2 sine of 0, that's 0. Minus 1. Cosine of 0 is 1. That's region 1. Okay? This is region 1 or area 1. Plus, and then we have to go ahead and deal with our region 2. So cosine of pi over 6, that is going to be, I believe, 1/2 plus 1/2 of sine of pi over 3, square root of 3 over 2. Okay? And then we have minus, okay? We have cosine of pi over 2 is 0. Oh, sine of pi is also 0. Okay, so let's see if we can't put this together and see what we have here. So we have square root of 3 over 4 plus the square root of 3 over 2 minus 1 plus 1/2 plus square root of 3 over 4. And that's what we have. Let's go ahead and multiply 2 over 2 here. So we have 1 square root of 3, 2 more square roots of 3. So 1 plus 2 is 3, plus 1 is going to be 4. So we have 4/4 square root of 3 over 4. So we have square root of 3. Before, we have 4 of these things, so it's going to be 4/4. Okay. Minus 1 plus 1/2, that's going to be minus 1/2. There's your answer. And if you want to plug that into a calculator, you can go right ahead and be my guest. But that's a very nice answer for how to do this problem. Almost all of these problems pretty much have 2 regions attached to them. First part of the problem is where do they intersect? Second part of the problem, set up the areas and actually integrate. Okay. Thank you very much for watching the video. Go study, and we'll see you in the next one.